Welcome to this recorded video that will go over the solutions to the activities in the lecture notebook for web scraping and input outputs that's in Module 5 of the Math 1376 course. So the first activity, Go Nuggets Go, asks you to read in the Nuggets team roster data from ESPN. So you can click on the link here and go to the page and then copy the URL from your web browser. You could also open up this markdown and just see exactly what that URL is as well from here, and you could copy and paste it from here. However you want to do it, I'll just go ahead and do it this way, is you should then create a URL variable. Now, you can't just copy this in like this. This will not work. This will and should produce an error. This is an invalid syntax, you see, because you have all these characters that are special reserved characters in the variable name. This has to be in a string format. And so doing it like that will be fine. So now I want to create a data frame that is for the nuggets that's based on, scraping this table of data from this website. So let's go ahead and use the pandas, that we've imported. We read the HTML. So you can there it is right there, read HTML. And then you put in your URL. Now, you sometimes will have multiple data frames scraped in. There's only one here. There's only one table here, but there might be multiple tables that are read in. So if we run this and we look at the data frame for the nuggets, first let's look at the length of it to say how many data frames are in this. Well, we see there's only one. And if you were to then print it out, it's in this, not nice format. This was covered in the lecture. And if you did it like this, then it's in this nicer format. So you say, oh, well, in that case, just return the first data frame, store it as the data frame for the nuggets. So now when you just call this as a variable, df_nuggets, it displays nicely. And you might say, what's going on with some of these first few columns? Like, why is the first column unnamed and have a lot of not a numbers? Well, if you look at this table, you'll notice that there's, in this first column, they have player pictures. And it's not reading that data in. It's a picture. And it's certainly not reading it in as a number, so it's not a number. And if you look at the name, you see it's Will Barton 5, Bol 10. What's going on there? Well, this happens to be their jersey number. Will Barton wears number 5. Bol wears 10. Jokic, of course, wears 15. You should know that because he's the MVP. You'll also notice that there's some columns that have, or some rows, and there's certain row data in certain columns that have no entries, and they use these 2 dashes there. So there's all sorts of things going on with this data. In this first column, because of the formatting with the hyperlinks for the name and the way it ends up getting interpreted when it was scraped was it had the name and the number just kind of put together. They just got concatenated right together. And then you see those 2 hyphens showing up here. So this is how this data looks. We've now read it in. So congratulations, you've completed the first part of this activity by just doing that. Now, we are asked to transform the salary into floats and label the column, right? So this, where it says salary here, as salary in US dollars, and change any missing salary data into not a number. And you'll notice there is some missing salary data for Marcus Howard. And you might ask why that is. Why do you think such important data may be missing? It won't always be. It depends on what the current makeup of the roster is and the information that's available. But I will tell you, there are these certain types of special contracts for two-way players that go between the developmental league and the regular NBA. They kind of go back and forth. And in that case, it's indeterminate what their salary is for the NBA portion because of the special nature of their contract. So that's sometimes why you have missing data. And you have missing data for colleges because some players went overseas, like Facundo Campazzo is from Argentina, I believe, and Vlatko Kankar, Nikola Jokic, he's Serbian, and he didn't go to college, although one of his brothers did play in the NCAA. So, there's lots of reasons why you might not have college data. Some players maybe go straight to professional leagues in some other countries as well. So there's even, I think, one of the Ball brothers ended up going, instead of going to college, I think he played professional ball in Lithuania and then Australia and then now is in the NBA. Anyways, there's all sorts of reasons why this data could be missing, but it's good to think about it and know why, because I do ask you eventually to change missing college data into a string that is not applicable. And then, anyways, we'll get to all that. Let's talk about transforming the salary into floats. Now, before you do this, you should actually look at what the salary data is. So if I just go ahead and looked at this data frame for the Nuggets, and I just looked at the salary data and I just printed it out, there we go. You see that, of course, this $ sign is attached, which is going to prevent us from presenting it as a float. And there's also these commas, which are not common when we just have a big number, like in LaTeX. If I do like np.pi, I mean, you can have decimal points, a single decimal point, but you just have these long string of numbers. And if I take pi and let's say multiply it by a big number, there's no commas here. There's no commas at all. So this is not in the format with the $ and the commas of what a float is. So this cannot be of type float at all. And in fact, if we looked at, let's say, the first one, the first salary, which is 13 million, which is for Will Barton here. If I look at that, if I print it out, hold on one second, there we go, print it out. You see with those tick marks, it's giving it away. It's a string. It's a string type. It kind of had to be. And in fact, if you could just go ahead and look at the type of it, and we see that it is a string. So you say, okay, well, it's a string, and a string, much like a list or an array, can be indexed. The various components of the string can be indexed. And we see the first component in each one is a $. So indexing from 0, there it is. It's the $. And that means that if we do some slicing, like do 1 colon, then we'll get the number that we want, except it still has those pesky commas. And so you go, well, how do we get rid of those commas? Well, how did we get rid of the hyphens when we were dealing with the height data for the Broncos? So the height data for the Broncos was in this format. I'll scroll all the way up real quick. Here we go. The height data had, like 5-9, 5 feet dash 9 inches, 6 feet dash 2 inches. There's no units attached to that, and it's in a different format than the heights for the Nuggets data, but we'll get to that. And we saw, well, that was in a string format as well. That prevented us from doing any kind of statistical analysis, like what the mean height would be, or the median, any kind of statistical analysis you might want. The variance in the height, we couldn't do anything with that. So I'm just scrolling down as I'm talking to get to show you what we had to do. So when I try to compute the mean, I got an error because these aren't numbers, they're strings. And the way that I had to figure it out was I had to split the height data according to those hyphens, because it was like some separation of the units. 5 was the feet, 9 was the inches. And if I split it according to that hyphen, I would get a list that had each component of the string on either side of that hyphen. So then I knew that the first component of that list was the feet and the second component was the inches, but they were in strings. So I had to cast them as integers to turn them into numbers. And then I would multiply the 5, for instance, by 12 to convert it to inches, and then add that to the second component cast as an integer to get the total number of inches. That was what was done here, and I also showed it in a function form here. I split the data, and then I take that first component of the data, cast it as an integer, multiply by 12, and then I add the second component of that data list from the height data, which is an integer, which is in inches, and I cast it as an int. So that's all the stuff I had to do there. So that's just a recap of something from the lecture that you should have gone through and watched and paid attention to. But let's talk about what we have to do here. We want to split this according to the commas. And if I do that, look what happens. I produce a list where the first component is what's in millions, the second component is what's in thousands, and the last component is what's in hundreds of dollars. So now, here's something to consider. You could create a function, much like we had for the height, transforming the height data for the Nuggets, where you take this number, cast it as an int, or I asked you to do this in floats, but it doesn't really matter. If you want to do this as integers, I said floats, but if you want to do as ints, it's going to work out because they're all in integer values. But if you looked at it there, then you'd say, okay, if you looked at the Broncos data, you'd say I would cast this as an int, multiply it by 1,000,000. I would then cast this as an int and multiply it by 1,000, and I would add that to this multiplied by nothing, because it would just be cast as the hundreds, it would be in the right units. So that's fine, that's one way to do that. Now, one of the issues with trying to code it up is not all the salaries are in units of millions. For instance, Austin Rivers was signed towards the end of the season because of an injury to Jamal Murray. And so his salary was not much because he only played a couple weeks for the Nuggets at the end of the season. So his total salary that they hired him on, the prorated amount that they had to pay him, was under $200,000. So the thing to think about is, how would you turn any arbitrary data that, like, once you get it into this form, where it's this list, how could you turn it into the right value without having to hard code or do something really complicated, like making like another loop? There's a few ways you can do this. Here's perhaps, I think, the simplest way. If you take this data, the list components, and you said, here's one thing to consider. So I'm just going to go ahead and say, here's a test. These are nice things to do where you break it down into components to figure it out. If I looked at that test variable is now this list, all right, with these components. And if I considered having a loop where I went for I in range of the length of my test, all right, if I did this and I had, let's say I created a variable that was temp salary, and I just have this as an empty string object. And then I took to temp salary and I added to it, right? So plus equals, I'm doing an in-place operator, each of these components of test one by one. And then, I'll not have a typo, temp salary. And then if I print what that temp salary is at the end of this is for Will Barton. Notice it is 13,723,214, but not with the commas. Now the type of this, if I look at the type, so I'm just going to have to create a whole bunch of code cells, so I'm just going to do it because we're playing around here. If I look at the type of temp salary, it's still going to be an integer, a string, because I never changed the type, but I did concatenation so that everything was in the right order. I really just want to get rid of these commas and have these things concatenated, and then I could cast it as an int. So I could do this, and then I can make temp salary equal to int temp salary, and now I've cast it. I'm storing it over as an int, and now I print it. It looks the same, but if I look at its type now, it's an integer. Or I actually really did say float, so let's go ahead and do float. It's float, and then you just see it's 0.0. That's really technically what I asked, so let's go ahead and do what I asked. So that's one way I could transform this. Now you have to think how you would code it up. So let's go ahead and make a function that does this process. Let's define the transformation, xform, transform, nuggets, salary to float. And then we're going to pass to it salary data, much like we passed height data in the Broncos function. And then I'm going to create an empty list that will have all the entries that I want. This is just going to follow kind of the same thing that I was doing. I'm just going to scroll up again, but you can do this for yourself. I'm just following the same type of format I did here. When I wanted to transform the height to inches, I'm going to transform here the salary to floats. So I create an empty list, and I append to that list all the things I want. I just have to loop through the length, like all the height data I had. I'm going to loop through all the salary data I have. So it's going to look very similar, but let's go ahead and make salary data float. That's ultimately what it is. It's a very descriptive variable name. And then I am going to go for I in the range of the length of the salary data that I'm passing to this. All right. And in that, I am going to look if the salary data entry is equal to this, because right there's some salary data that's not there, and I want to first basically turn those to not a number. So if it's not in one of these formats where I'm going to do this conversion, I need to just go ahead and convert that to not a number right away. So if it's not if it's this blank entry that they use 2 hyphens for, then right away I want to go ahead and append to my float list here np.not a number. So now it's not a number. Otherwise, it's in the format. Else, it's in this format that I want to compute to do what I've basically shown up here. And in that case, what I'm going to do is create a temp salary, like I'm showing here. And I'm going to loop through for j, because I is already spoken for j in range of the length of this particular salary data. In this case, it's this, well, it's basically what I'm asking for here. So it's that salary data let's say I, right? Because instead of 0, because I'm going to have the ith one, so it's not just the 0 anymore. And then I put this on here, and that will split it up. Now, this looks kind of unreadable. At this point, I would say this looks a little unreadable. It's probably hard to follow. So I'm going to go ahead and take that out. Once you start writing, you might change your mind about how it should look. And I want to go ahead and create a, let's say a salary list, a temp list. Maybe I'll just make it a temp list, which is given by the ith salary data without the $sign, where I've taken out the commas. That's in temp list. That makes this quite a bit easier to look at. Temp list here. And then I am just simply going to take the temp salary and concatenate to it these components in order to get the right salary without the commas. So this is going to be temp list J. And then I'm going to, I don't really need to do this anymore. What I'm going to do is the following. I'm going to say my salary data float is appended to this temp salary variable, but cast as a float. I'm just going to do that all in one instead of creating another variable name that ultimately just goes there. That is this, or basically just do that operation can just be simplified as taking that float and putting it there and appending that value to the salary data float. So that's it. Now I want to return this to the user. I don't say this, but what I'm saying is I want you to transform the salary into floats and label the label into this. I'm talking about the data frame. I want this label to change. So I want to return this salary data float to the user. See, don't do something silly like me. 2 equals to check equality. I had that typo there the whole time. There, let's fix that. Yeah, that's run. And let's go ahead and look at salary data float. Now this is defined it's not this one. It's here. I'm assigning this output into this a variable of the same name, but this is, so that I'm outside the scope of the function. So, I return it and I actually assign it to a variable of the same name, but you could call it whatever you want. But I'm going to now call this function and I'm going to pass to it the nuggets salary data. So let's go ahead and run that. And you could say, all right, did it work? Let's print salary data float. And you see the numbers are in float, like 13,723,214. That's Will Barton's. Bobo was 2,058,240. Yeah, 2,058,240. And here was Marcus Howard's, not a number because they don't have it for him, at least at the time of me making this video in the current roster construction. So that's perfect. I have the data in the format. I'm just kind of doing, proofs of concept or sanity checks along the way. And then what I want to do is I want to overwrite the nuggets data, the salary data, with this float. And if I do that, and then I look back at the data frame, you'll notice the format of that data has changed. But I still need to change the column name, right? And so to do that, you can, I'll just go ahead and do it right here. I can rename, and then I can just say you can do this all at once at the end, but I'm just going to do it like this, columns, and then I'm going to put salary, and you just change it to salary in US dollars. That was what I asked you to do, and I want that to be done in place is true. So if I do that, and now I look at the nuggets data, we see that that salary in US dollars is changed. So this gets us through this first part of this activity. I know I'm going a little slow, but I'm showing you kind of a stepwise how to think of it and do little tests and develop the problem solving skills to then develop a function, something like that does exactly what you want. And so we're almost through this activity. That at least transforms the salary into data, salary into floats, and the label of the column. I ask you to change the missing college data into a string where it's not, it's just not applicable. So That's a fairly straightforward thing to do. So let's go ahead and do that thing next. So change the missing college data. I asked you why. You should explain why, like in the markdown cell. All the questions that I have in there, you should address in this markdown cell at the end. So let's go ahead and find all the indices where the data frame, the college data, here we go, where that college data is equal to this, 2 dashes, right? So it's, there's 3 components here. And we want, for this NP where we just want to return this. First thing, this returns the indices where this is true. If you put the 0, if you don't put the 0, let's look at what happens. If you print this index, you have this array, and notice it returns this tuple where what you want is the first component of the tuple. And that's why you do it like that. Now you see it's 2, 3, 9. So those are the components. And it makes sense, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we get the indices where we have the missing college data. So I have that there. I'm just going to do this in this one thing. And then I'm going to go ahead and take the data frame for the nuggets. I'm going to take as a location these indices, and I'm going to just take the column, which is the college, and I'm going to make this equal to not a number. And that's it. If I look at the nuggets data frame now, I did that, but of course I didn't save it. Data frame, actually, no, I think I did. Let's just go ahead and see. Let's print it out. Yep. I didn't have to resave it because this was done in place, right? I'm taking a location and I'm actually setting this nuggets data equal to that. So there you see it. You now are halfway through this activity. Like if you stopped right now, I grade each of these instructions like they are the same thing. So it's 1, 2, 3. So that's 60% of the work basically. And if you didn't do these last 2, at least you're getting 60%. Well, let's talk about changing the weight and the height data. So to transform the height data, there's a little bit of a difference here, right? Now we have this tick mark, like a single quote versus a double quote, which is different than the Broncos data where we had a hyphen. It would be like 6-6 if this was in if Will Barton played for the Broncos and we're looking at him in the Broncos roster. But it looks like 6'6" with these units attached with the familiar notation in the U.S. system for feet and inches, right? So we want to change those. Again, the instruction is to change the. Oops, I scrolled up too far. My apologies. We want to change the weight and the height data into floats. Let's do the height data first because it's similar to what we've seen. So if we were to just look at the height data, let's go ahead and do it. Kind of take it the same way. So if I looked at the height data, there it is, like 6'6". If I look at the first entry, which is Will Barton's height, we see 6. And notice this. There's that right there. What's going on? Well, tick mark is like a special character. And so if you're going to use a string, if you're going to define a string with a single tick on each side, and you want to have in your string like a tick mark showing up, you need to put a backslash before it so it's interpreted correctly. So if you actually look at, let's say, the second, the first, let's say the second component, right? So 6, we know, well, I'll just do this. There's 0, there's the 6. Here's 1. It's the tick mark. So you go, wait a minute, what's going on? I thought it would have been the backslash. You look at the second, it's that. Third, it's that. So what it's showing you is how if you wanted to write this as a string, in order for it to interpret it as a string, this is interpreted as a single character. So that might seem a little confusing, but you just need to understand, like, that's a single character right here. And we want to then just split this up. Like, I mean, we can, there's a few ways you can do this. One thing to realize is that nobody is 10 or more feet. So that first tick mark shows up in this data set as the second component. So component, in this case, indexed by 1. Excuse me. Do it like this. That's Bulbul's height. He's rather tall. I've met him. He's very tall. There we go. So there's that single tick mark. And then this, after that, you basically just want to use, let's see. So after that first one, and then you go 2, there's a space, an empty space, because they have like 6 foot or 7 foot, and then there's a space, and then there's this number. You have to understand the formatting that's going on here. And if you look at that formatting, you realize you really just want to take this in this first number, which is in feet. And that's, again, bol because I have the 1 there. And if I look at the height of bol and I look at going from, so it's 0 and then 1 and then 2, and then you can have either 1 or 2 more digits. You basically want to go you want to start doing slicing. You want to go from 3. So let's look at like Facundo Campazzo is 510. So 0, 1, 2, 3, 4, but you don't want 5. You don't want this. So you could just say, I want from the third component, and I want to go up to, but not including the last component. And if I do that type of slicing, there's the 2. And it works for bol, he's 7'2". And it works for Facundo Campazzo, who is 5'10". So that's a way to do some slicing. So again, just, make the problem smaller. Look at some specific data. Look at some of the characteristics of the data. And when you see that, you say, I think I see how to make a user-defined function now that can transform nuggets data from the nuggets height data from these units of feet and inches with the format that's given into floats. So the way we could do that, we're going to transform nuggets height data to a float. We're going to give it the height data. And we're going to do the same thing we've always done. We're going to create an empty list. We're going to go for I in range of the length of that list. So, that's not the height data. There we go. I'm not passing the whole data frame. I'm just passing a particular aspect of the data frame. So when I do that, then what I say is I'm going to do the splitting and things as before. So I'm going to do this a little bit more explicitly here but you can write this in different ways. You don't have to write it the way I'm about to present it. You could go look at how I did it for the Broncos and try to make it your own. And I really encourage you to do that. So the first thing I'm going to do is just get feet data, and I'm going to put that as int, and I'm going to get the height data 0. That's going to give me the height data. I'm going to get the inch data, and I'm going to cast it as, I'm casting these as ints, and I'm going to go again from 3 to -1. And then I'm going to say that the height data as a float, what I'm appending to that is I'm taking the feet data times 12, and I'm adding to it the inch data. And then I'm just going to return that height data float. There we go. So let's go ahead and look at this. So if I take height data float and I do the transform of the nuggets, height data is the float function, and I pass to it this nuggets height data. Run that, I'm going to need to create some more cells. You need to create a lot of cells in this one. If I look at the height data float, there you go. 78, 86, 70, 80, 78. These are all in the inches. So 75. That's fourth from the bottom. That's 6'3". That's how tall I am. So let's see, 6'3". Yes, it seems to be working correctly. That was my little sanity check here. By the way, funny and true story. I am 6'3", and I'm 75 inches, and somehow on my Colorado driver's license, they have listed me as 7 feet 5 inches. I think that they somehow did some weird conversion in their system, and they got to 75 inches and then listed it as 2. They separated out, like the way that they were transforming the data, it messed it all up, and I ended up being 7'5". So on my official Colorado driver's license, I am listed as 7'5", which is completely absurd. I think I would probably be the tallest person in Colorado if that was true. At any rate, we want to then just go ahead and store this as the nuggets data. I think I did say to do this as float, so I'm going to go ahead and edit this a little bit. So I said convert it to floats and relabel these columns where we have height as inches. So I'm going to, in my function, just because I said to do that, I am going to do it here. I'm going to cast, even though that data is in integers, I'm going to cast it as a float, because sometimes people are like half an inch, different inches. And in fact, in that case, the format of the data might be a little different. But in this case, I'm just going to do that. So I'm casting it as float. And if I do that, I go, okay, look, it is perfectly, given in floats now. And in this case, I want to take the nuggets height data. I want to rewrite it in terms of this float list. I want to look just to make sure that it worked properly. And I see that here's the height data, and you see it's not in that format where it was like 6'6" again for Will Barton. It's 78. He's 78 inches. Bol Bol's 86. Jamal Murray 75. I wonder if he's actually 75. I've walked by Jamal Murray before. I feel like I'm a little taller than he is. I hope he doesn't watch this video. Okay, I love you, Jamal Murray. Anyway, let's keep going. So we're halfway through this in terms of the height. I mean, I haven't renamed it as inches yet, but I think you could see that this is pretty easy to do, to rename that. You just pretty much base it like on this one. At this point, I'll just go ahead and rename this data here as, we'll rename the height as height in inches. In inches. So, just height inches, not in inches. I'm just checking my instructions. That's basically the right idea though. There we go. So we're halfway done with that instruction. The other thing is to do it with the weights. Look, with the weights, there's no conversion. You just have to drop the pounds. That's all you have to do. So, and then I say make it into a float. So that's a much easier thing to do, but I'm just going to go ahead and show you let's look at some data here. So let's look at, if we take the Denver Nuggets and we take the weight data, and I look at Will Barton's weight, 181 pounds. And pretty much everyone is in the hundreds of pounds, so it's the first three entries. And so that's just 0 to 3 because that would slice. So if I do 0, 2, 3, that's actually to the first 4 components. It's 0 up to and not including the 4th component because, again, the Python indexing starts at 0. So, I'm sorry. 0 is, that's a whole object, that's a string, so I have to do it here. 0, 2, 3. There's your 181. And then you could just go ahead and turn that into a float because people can be like fractions of a pound. So it makes it more sense, I think, to me to represent it as a float. So then just seeing that, you can create your, transform nuggets weight to float and give it weight data. And then create your weight data float as an empty list. Go for I in the range of the length of the weight data. And then go ahead and just do the following. Just append to that list, casting as a float, the weight data, the ith one that you have, and you just want to take the first 3 components. So you do that little slicing, and then you just return it. This is a very simple function compared to the other ones we had. And so I think at this point, I'm not going to finish this off because I think you can figure it out for yourself. You just run it, much like I was doing here, except it would, it's a different function now. It's a different variable name. You store it, and then you can look at the data frame, make sure it's appearing properly as floats, and then make sure to change the name as weight pounds, right? Just follow the instructions. So make it as weight pounds. And then the last thing, and I'm not going to do this, is compute some statistics on certain columns and comment on results. Like look at the average salary, look at the median salary, look at the average weight, look at the max weight, the min weight, the max height. You can look at all sorts of different ways to do summary statistics. I'm just giving you some basic ideas. And make some comments like, what's the average height of a Nuggets player that was, on the roster for this most recent season? Depending on when you do this, maybe this roster data will be different. So, you could see I'm actually a little curious. So I think if we looked at it and we looked at Denver, the data frame for the Nuggets, and we looked at and we did let's say this, the mean, then we see, okay, the average age is 26. The height in inches is like 78.5. So a little over 6'6", and then the salary in US dollars is around $7.4 million. That's pretty good. It's good to be a Nugget in this day and age. So I'm actually going to stop this video here. I'll make some shorter ones for the other activities because this one's already gotten kind of long. But thanks for listening.